from the Riemann sum. Okay, that what we did as the example, that we did the midpoint approximation, the left and the right end approximation. For n equals 4, we know exactly how many areas that we have to add them up or find the sum. So in the case that you have, let me see, explain in the less confusing way. So from the function that is provided, right? The function which is non-negative and continuous on the closed interval AB. And we know the n as a number of the subintervals, equal subintervals. And the delta x is computed by b minus a divided by n. You know the left bound, you know the right bound. As n approaches infinity, that means the b minus a divided by very large quantity, the delta x approaches 0, or the bar is very narrow. It's very, very skinny bar. Line them up like this. So then the approximation is so close to the exact value. And the idea of this is the area is from the sum of the area 1, area 2, area 3, up until n of them. And right in the notation is called the summation notation, or the sigma of the area index I from 1 to n. Okay, and the area is formed by the height, which is the function value, times the width, which is the delta x. Right, the area is the height multiplied by the width. Okay, multiplied by the width. So, and we know that delta x is the same as dx. The function f of x still represents the height of the function. But if you take the limit as n approaches infinity of this summation, recall this is a sigma notation, represent the sum. And the S is the letter to represent the sum. So when we take the limit, the letter S is stretched into kind of the stretchy S. That is the integral sign. Okay, integral sign. So when you take the limit of the summation or the limit of the Riemann sum, this limit and summation is equivalent to the integral sign. The integral sign again is the S that stretched out both ends. That represent the sum of the small areas together. Okay, so that's why the formula for the area under the curve that's related to the integration is in the form of the integral. It's called integral from A to B. What are A and B again? A and B are the left end and the right end of the graph. What is the function? The function is the one that given by the problem that is non-negative and continuous. The dx is the width, and fx is the height of the bar. So the height times the width, that is the area. The integral sign is the sum. So the sum of the area, that is the notation for the area under the curve. So we are back to the integral sign. And in 6.1, the integral sign, what we did, so in 6.1, we did the problems involving the indefinite integral, the indefinite, because we don't have anything on the bottom, we don't have anything on the top. We have to find the antiderivative of the integrand that comes out to be the uppercase notation plus the constant of integration. So for this case, indefinite integral. But for this section, now the area is represented by, it's called the definite integral because it's defined at point A and point B. A is called the lower limit. Nothing to do with the limit value, okay? Just called lower because lower limit, lower one. And the B is called the upper limit. So this is the difference between indefinite and definite integral. You have lower limit, you have upper limit. You still find the antiderivative, but you do not add C. What you have to do as the additional work, you're going to compute the function value at B, which is the upper limit, subtracted by evaluating the antiderivative at the point A or the lower limit. So you're going to do more algebra work for the definite integral. Okay. The property, the power rule, the rules all are the same, except the last part that you have to do more algebra work. Okay. So this is about the definite integral. So I'm saying this one is called the definite integral. Integral, integrate, integration, the integrate to combine them together. Combine means the sum of what? The sum of the small areas. Okay, so the common properties, the definite integral from point A to point A, see the lower and upper limit are the same. This one means when you have the graph and the point A and the point B, if A and B are the same, so that means you do not have the area. So no area between the curve because start and stop point are the same thing. And for the second part, this is the constant multiple. The constant multiple k to the function is the same as the constant multiple, the definite integration. The sum, the integral of the sum is the sum of the two definite integrals. So very straightforward. And the rest of them gonna be based on the basic antiderivative rules that you saw in 6.1. Okay, let's do the example. Now, I will go slow step by step. You stop me if you have any question, okay? Again, you're gonna need the antiderivative rule. Need antiderivative rule. Maybe more than one rule. And also compute the function value at the end. So at A and B, lower limit, upper limit. Okay, put the note here. So for the first example, you have the point A as 1, the point B as 2. A is called lower limit. And B is called upper limit because it's the upper portion. Okay, limit. Now, we are going to, first step, we're going to find the antiderivative. So I'm going to set it up down here, right in the bigger one. 2x dx, I'm going to put the note. So this one is the constant multiple. That means the integral of the k times the function is the same as k times the integral of the function. Okay, so the problem becomes 2 times the integral from 1 to 2 of the x with respect to x. And then at this point, I'm going to use the power rule because this is x to the first power. The power rule said the integral x to the power r with respect to x is x to the r plus 1 divided by r plus 1. Make sure, I have to add c, right? But this one is definite integral, so you don't have to worry about plus c. So you're going to have to make a note, r cannot be -1, otherwise it's undefined. Since r, in this case, r equals 1, so it's good. So you can go ahead using the power rule. The power rule in this case can be x to the power 1 plus 1. Whatever the number as a result from the sum, you use it as a denominator. Okay, the same number. The difference of the definite and indefinite integral, you do not add c. What you have to do, you're gonna have to put the bar in the back. So this at this step, this is already antiderivative. Okay, no AC, because you have upper limit, lower limit. You're gonna put the bar instead of the integral sign. Integral sign in the front, the bar in the back. Okay, you have integral sign, no bar. You have the bar, no integral sign. So you're gonna indicate that the lower limit x equals 1, upper limit x equals 2. You can write just 1 and 2, not X notation, that's fine, as long as you know that the next step you are going to replace with the 2 one time with the 1 one time. So I'm gonna clean up a little bit. Right now I have 2 times x to the second over 2. I'm gonna evaluate from 1 to 2. What I can do here, I'm gonna clean up before I replace the value in. My problem is cleaner to be x squared, evaluate x equals 1, x equals 2. By default, you're gonna replace the upper limit first. That means the number 2 first to the second power minus evaluate at the lower limit 1. And the number becomes 4 minus 1 or 3 as the result of part A. Okay, so I'm gonna put the note here. So the upper limit, the lower limit, replace it into the x squared. In the graphical way, what does it mean for this definite integration? You have the line y equals x, y equals 2x. Okay, at 2 gonna be 4. So you find the area of this is called trapezoid, right? So this is the line y equals function of x, which is 2x, or the integrand here. And from point 1 to point 2, from point 1 to point 2, the area, the shaded area here can be computed using the definite integration. But if you do not use the definite integration, you can look at this as the sum of the two areas, the area of the rectangle and the area of the triangle. So to verify, this is the area as area 1 plus area 2. The area 1 is the area of the rectangle. The area 2 is the area of the triangle. The first one, the width is 1, the height is 2, so 1 multiplied by 2. And then the next, this is the height gonna be 2, and but the base is 1. So 1/2 times 1 times 2. And when you simplify, you get 2 plus 1, which is the same result as what you did with using the definite integration. So that's kind of to explain in the graphical way to verify the answer and verify what does it mean by the use of the definite integration to represent the area between the curve and the x-axis.